Okay, we're at almost wrapping up Chapter 5. We're going to analyze graphs of polynomials, which we've sort of been doing along. So this section actually helps us put a lot of things together, and so there really isn't much new information, a little bit. So the first is that if I have a degree of 5, if I have a polynomial, this could go on, and I have a degree of 5, it has at most 4 turning points. If I have a polynomial with a degree of 3, it has at most 2 turning points. So the general rule if the degree is n, then there is at most n minus 1 turning points. That doesn't have to be 4, that doesn't have to be 2, but that's the most there will be. And if I know a little bit more about the function, if I know it has n distinct real zeros, then there will be exactly n minus 1 turning points. So for example, if I look at this cubic, this is the graph of the cubic, it has 3 distinct real zeros, and the only way for that to happen, this is a cubic, so I've got to go down and positive, down to the left, up to the right. The only way for that to happen is if my graph turns twice. So in this case, 3 distinct real zeros, therefore 2 turning points exactly. So you're going to be asked to graph functions for a couple of these, numbers 3, 7, and 9. Really at this point, it's mostly a sketch. So if this is my function, x plus 1 squared times x minus 1 times x minus 3, I can identify 3 zeros. This zero would be negative 1, this zero would be positive 1, and this zero would be 3. Now I know when I multiply all these together, this will be an x squared, that'll be an x to the first, that'll be an x to the first. So overall it's going to be a degree 4. I'm going to get an x to the 4th once I'm done multiplying all these x's together. And if this is positive, I know this thing has to go up and up. So I'm expecting it to do this. And then if I plot my zeros, I have a negative 1, a positive 1, and a positive 3. So how is that going to happen? If I cross and cross and cross, I end up down here. Well, this guy is even, so that means I'm going to bounce off of that 0. I'm going to bounce off the axis. I don't cross. These guys are odd. That's a 1 and a 1, so I cross there. So fine, I'm going to cross, and then I'm going to cross. And again, in order for that to happen, I would have to have 1, 2, 3 turning points. I don't exactly know what this graph looks like. You guys could use GeoGebra, your graphing calculator, double check it. But that would be an initial sketch given these ideas. Now the new thing is that if I've got an even degree for this factor, it's going to bounce. If that's a 2, a 4, a 6, an 8, I'm going to bounce off the axis. I might be bouncing down here depending on where I started. And if it's a 1, 3, 5, 7, 9, etc., I'm going to cross the axis. All right, let's look at this function. Again, I can identify this 0 as x equals 3. This one I can't factor. We'll deal with that in a minute. So again, this is an x to the first. That's an x squared. So my degree is to the 3rd. It's positive, so it's going to go down to the left and up to the right. Expect it to go down here and up here. I know I cross at 3. Let's see what happens when I find the zeros here. I'm going to use the quadratic formula. A equals 1, b equals 1, c equals 1. So negative b plus or minus the square root of b squared. B squared will just be 1. Minus 4 times a times c, so that's just going to be minus 4 over 1, all over 2a is 2. So I have negative 1 plus or minus the square root of negative 3 all over 2. So what I know about that, that's imaginary. So again, I have 2 imaginary roots. I have negative 1 plus I root 3 over 2, and I have negative 1 minus I root 3 over 2. They always come in pairs. So 2 imaginary zeros. So what's this thing do? I don't know. It's going to cross here somehow. And then I think if you graph it, it actually does something like that. It's a little steeper. But just this idea of knowing my zeros, knowing that imaginaries don't cross at all, knowing I'm looking for 3 zeros. If you think about Descartes' rule of sign, 1 real, 2 imaginary, it all adds up. In numbers 15 and 17, they give you a graph. They ask you to estimate the location of the turning points. And then is it a max or a min? I don't remember what this graph is, but I'll say, okay, let's say this looks like a -2, -4, and let's say that looks like a 3, -9. So estimate the location. This would be a max, a local max we call it, because this actually doesn't have a true maximum, it goes on forever. And this would be a local minimum. Estimate the real zeros, there's only one here. Let's call that 5, 0. And then the least degree, well, if I have 2 turning points, I mean, again, I only have 1 0, so is that an x to the first because there's only 1 0? Well, I have 2 turning points. So the least degree I would have to be is 3, 1 more than the number of turning points. Yeah. So the last couple have to do with graphing them and actually finding the maxes and the mins. You can do that on your calculator or GeoGebra. I'll make a couple videos for those.